All right, so these notes are on adding and subtracting rational expressions. And before we go too deep into that, we're going to go ahead and remember how to add and subtract fractions first, because when you're adding and subtracting rational expressions, that's basically what you're doing. So if I wanted to add 1/12 plus 5/12, I wouldn't say that was 6/24. I would say that that was 6/12, which is 1/2. If I wanted to add 1/15 plus 3/5, I can't just add those together and say that that's 4/20. I have to get a common denominator. So I would have to take this fraction right here, and I would have to multiply it by 3 on the top and 3 on the bottom to get that common denominator. And then this problem would become 1/15 plus 9/15, and then that would give me 10/15, which I could reduce to 2/3 when I divide the bottom and the top by 5. So when we are adding and subtracting rational expressions, we have to do the same thing. We have to make sure we have a common denominator first, and then we can go ahead and add, we can go ahead and subtract. So first problem, we're going to do 1/5x plus 1/6x squared. And what I have found that is helpful for students is if they take those denominators and break them up a little bit. Sorry, there we go. So I'm going to think of this denominator as like a 5 times an x, and I'm going to think of this denominator as a 6 times an x times an x. And so that means that our common denominator is going to need to have a 5, and it's going to need to have a 6. And then this one only has one x, but this one has 2 of them, so it's going to need to have 2 of those x's. So that means that our common denominator is going to be 30x squared. So my next step is to fix the fractions to make sure that they have that common denominator. So my first fraction, it has the 5 and it has an x. What it's missing is a 6 and another x. So I'm going to multiply it by 6x on the top and 6x on the bottom. The second fraction has a 6, an x, and an x, but it's missing the 5. So I'm going to multiply by 5 on the top and the bottom. So at this point I have I have 6x over 30x squared plus 5 over 30x squared. And so I have that common denominator of 30x squared, and then I have 6x plus 5. At this point, you would go back to what we learned on the first day, and you would ask yourself, can I factor the top? Can I factor the bottom? Can anything cancel out? And nothing can cancel. The top is not factorable. And so we would say that we are done, and that is the final answer. All right, so let's go ahead and do some more problems like that. So we're going to go ahead and say we have 4x over 4xy minus 6y over 4. And so I'm going to start with that same step where I take the denominator and kind of break it down a little bit. So 4xy would be like 4 times x times y, and then the 4 I can go ahead and just call a 4. And so that means that my common denominator is going to need a 4. And it's also going to need an x, and it's also going to need a y. So 4xy is our common denominator. So the first fraction has all 3 pieces to it. The second fraction only has the 4. It does not have the x or the y. So I'm going to say xy on top, xy on bottom. So now I can go ahead and rewrite my fractions. So I have 4x over 4xy minus 6 xy squared over 4xy. So my denominator is 4xy. And then for the top, I have 4x minus 6xy squared. And then just like the first day, we're going to go back and we're going to see if we can factor anything. And with this problem, you can actually factor. You can take out a GCF of 2 and a GCF of x. So I'm going to take out the 2x, and that would leave me with 2 minus 3y squared. And then when I look at that, I can see that the x cancels with that x, and that 2 goes into 2 once, and 2 goes into 4 twice. And so that means that my final simplified answer would be 1 in the front, so I don't really need to write it. So 2 minus 3y squared, and then on the bottom I've got 2y. All right, let's try another type of example. So for this one, we're going to try x minus 4 over 4x squared plus 2x minus 3x over 2x. So since this problem isn't just monomials, so the first two examples we had were just one term over one term, one term over one term for everything. Here we have a binomial over a binomial. So that means when we look at the denominator and we kind of break it apart, we're going to do that by factoring. So this was actually factoring. It's just factoring that's a little bit more like middle school, when you're saying like, what are the factors of 12, or what are the factors of x cubed would be x times x times x. So here when we say factor, then we mean more like GCF or diamond or whatever. So this problem has a GCF of 2x, and then the leftovers would be 2x plus 1, and then this one is just plain old 2x. So that means that our common denominator needs to have a 2x, and it also needs to have a 2x plus 1. So if we look at the first fraction, it has both of those pieces in the denominator. In the second fraction, it only has the 2x. It needs the 2x plus 1. So I'm going to go ahead on the top and the bottom. I'm going to multiply by 2x plus 1. And so now I can rewrite my fractions. I have x minus 4 over, and I would go ahead and use the factored form. And the reason I'm going to leave the denominator in the factored form is because at the end of the problem, maybe the factors could cancel. So that last step we typically do is factoring and canceling anyway. All right, so on the top, I have x minus 4. And then I have a negative 3x that is being distributed. So then I have negative 6x squared, and then I have negative 3x times 1 would be negative 3x. All right, so this is negative 6x squared minus 2x minus 4. And I'm going to go ahead and take out my GCF on the top. I can definitely see I have a GCF of negative 2. So 3x to the third plus x plus 2. And it looks like if the top factors any more, that the top would have to be a slide divide problem. So let me just double check and see if we can divide using slide divide. So 3 times 2 is 6. So I'm going to check to see if there's anything that multiplies to a positive 6 but adds to a positive 1. And there's not. If it had been negative 6, we could do it, but we can't do it with positive 6. So that means we are done factoring the top. This isn't factorable. But we can definitely cancel out those 2's. And so now I can go ahead and say that my simplified answer is negative of 3x, and I wrote cubed, but I meant squared. 3x squared plus x plus 2 over x times 2x plus 1. And that right there is a good answer, or you could take that negative and distribute it, and that would be a good answer as well. Okay, let's try another one. So for this one, we're going to say we have 5 over a plus 3 minus 3 over a minus 6. And so here you can see the denominators are kind of like a factor on their own. Like this one is kind of like a plus 3 is a factor. This is kind of like a minus 6 is a factor. And so our common denominator would be a plus 3 and a minus 6. And so that means that the first fraction is going to need an a minus 6. And the second fraction is going to need an a plus 3. Okay, so for the first fraction, we have 5 times a minus 6. And again, I'm going to leave the factored form. So on the top, I have 5a minus 30. And then here, I have negative 3a minus 9. And I have that common denominator of a plus 3a minus 6. So 5a minus 3a is 2a. Negative 30 and negative 9 makes negative 39. And we're done because 2 minus 39 doesn't factor. And so none of the factors could cancel out. All right, we're going to go ahead and do one last problem. So if we have 6m over m minus 2 minus 4 over 3m plus 5, then this is kind of like the previous problem, so it's kind of like the m minus 2 is just a factor on its own, and then like the 3m plus 5 is a factor on its own. And so the common denominator is going to need the m minus 2 and the 3m plus 5. So the first fraction needs the 3m plus 5 on the top and the bottom. And the second fraction needs the m minus 2 on the top and the bottom. So I'm going to go ahead and think about what happens when I distribute. So I have 18m squared plus 30m minus 4m plus 8. And then I do have that common denominator of 3m plus 5 and m minus 2. And when I look at that problem, I do have some like terms I can combine. I have the 30 and the negative 4. So I have 18m squared plus 26m plus 8. And on the top, it looks like I can take out a GCF of 2, but taking out a GCF of 2 would not do us much good because that GCF of 2 is not going to cancel with anything if we take it out. I can also tell, I'm just going to go ahead and write this down real quick. If I were to take out that GCF of 2, this would have been a slide divide problem, and we would have been looking for numbers that multiply to 36 but add to 13. And I know that there's, 9 and 4. That really does factor. The odds that this is going to factor and actually cancel out are not good. So I'm going to go ahead and do this anyway. You don't have to write this on your notes. But so over here, so we have 2, we have m plus 9, m plus 4. The number that we slid was 9, so I can go ahead and divide by 9. And so these are the factors, but you guys can see that if I put this factored form on the top, it doesn't cancel with anything. And so if it's not going to cancel, you don't really have to do it. So this is a good answer. Or if, like me, you did all that factoring work and you don't want it to go to waste, then you can go ahead and say this is your answer. So both of them are good answers. It's just that the extra factoring was some work and then it didn't pay off in the end.